All right, so now what I'm going to do is I'm showing you how to use the quotient rule or the power rule. Now this problem that I have written up here, you can use either one. It's up to you really. So I've got this problem, f of x equals x squared, and I'm multiplying that to this other fraction, which is 3 over 2x to the 7th. And I'm going to show you how to use the quotient rule and how to use the power rule using the exact same problem. The reason we can use both of them is because I'm not forced to use the quotient rule. There's nothing being added on the bottom of a fraction. So I can easily just use my power or my quotient rule. It doesn't really matter. So I'm going to show you how to do the quotient rule first. I'm going to show you how to use the power rule. We're going to get the same thing for both problems. All right, so what I'm going to start doing is I'm going to rewrite this first. I'm going to rewrite it as 3x squared all over 2x to the 7th. That x squared gets multiplied to the top of my fraction. All right, that is what I'm going to use my quotient rule with. All right, now when we take our derivative, remember it is your bottom function, which is 2x to the 7th. You're going to multiply that by the derivative of the top function. Derivative of the top is 6x. I'm going to subtract. Now flip it. I'm going to multiply or take my top function, which is 3x squared, and multiply it by the derivative of the bottom function, which becomes 14x to the 6th. And I have to divide that by my bottom function squared, so it's going to be 2x to the 7th squared. So remember, quotient rule says bottom times derivative of top minus top times derivative of the bottom all over your bottom function squared. All right, now at this point we just got to do some distributing, or do some multiplying. So multiply those terms together, you get 12x to the 8th. Multiply your second terms together, you end up getting 42x to the 8th. And all of that, I'm going to square my bottom now, and I end up getting 4x to the 14th. Now, combine like terms on the top, you end up getting negative 30x to the 8th. That is being divided by your 4x to the 14th. All right, I'm going to simplify. When I simplify that stuff, I end up getting negative 15 over 2. And then when I simplify my variables, I end up getting x to the 6th on the bottom. So that right there is using the quotient rule. Now I'll show you how to use the power rule. Same step, same first step. I'm going to write it as 3x squared divided by 2x to the 7th. I'm not done rewriting this. I'm going to simplify it even further. I'm going to write it as 3 over 2x to the 5th. Still have to rewrite it one more time, because if we're going to use power rule, we cannot have our variable on the bottom of a fraction. It's actually going to be on the top of the fraction. And remember, when I move it from the bottom to the top, it's actually going to become negative on top. So I have this function, 3x to the negative 5th all over 2. That's going to be using my power rule. So I'm going to go ahead and use my power rule that says take your exponent, multiply it to the coefficient in front, and subtract your exponent by 1. So negative 5 times 3 gets me negative 15. When I subtract 1 from my exponent, I get negative 6. I'm still dividing that by 2. The last step that I have to do is I'm going to have to go ahead and make that a positive exponent. So I'll move x to the negative 6 to the bottom. I end up getting negative 15 over 2x to the 6th. Either way, we got the exact same answer. Depends on what you want to do. Do you want to do simplifying at the end, or do you want to do simplifying at the beginning? And the only reason I was able to use quotient or power rule, I can use either one, is because I was not adding or subtracting on the bottom of this fraction. If I have addition or subtraction on my denominator, I am forced to use the quotient rule. This is not the case. I can use either or.